Hello, honors pre-calculus. Today we are starting section 6.4, and it's all about dot product. The dot product of a vector, actually of two vectors, I should say, is something that we find by doing, in this example, u dot product with v. We just do u1 multiplied by v1 plus u2 multiplied by v2. Super easy. When we do this, we will always get a scalar. We'll get a number. We're not going to get a vector anymore when we use the dot product. We're going to get a scalar. There's a few properties that we can use with the dot product. If we do u dot product with v, that is the exact same answer as switching them around. So that would be the commutative property. And the zero dot product would be zero. We can use the distributive property. And then this is an interesting one right here, number 4. If we do the dot product of a vector with itself, it equals the magnitude of that vector squared. And then the last property says that if we have a scalar and we multiply it by a dot product, we could also rewrite that as a scalar times one of the vectors and the dot product with the other vector. And it doesn't matter which vector gets that scalar. So here's a few examples of finding dot products. The first 3 are just find the dot product. So 4 times 2 plus 5 times 3, 8 plus 15, 23. Dot product 23. Okay, the next ones, if you want to try any of these on your own, you can pause the video and then check your answers. I'm going to just keep doing them. So we've got 2 times 1 plus -1 times 2. So I've got 2 plus -2, which is 0. And then with this dot product, 0 times 4 plus 3 times -2. So you get 0 plus -6, which is -6. And all of those ended up as one number. Here's using properties of dot products. This one right here, if we have a dot product inside of a parenthesis, and then we're going to multiply that with another vector. I'm just going to do what's inside the parenthesis first. I'm going to do the dot product of u times v. So I'm going to do -1 multiplied by 2 plus 3 multiplied by -4. Oops, that's supposed to be multiply. And that gives me -2 plus -12, so -14. So that's the answer in the parentheses. Then we're going to multiply that with vector w, which is 1, -2. And because the dot product of u and v ended up being a scalar, we just now distribute that number into the vector, and we get the answer to be -14, +28 as a vector. Then question B says u dot product with 2v. Now you could take scalar 2 times v and then do the dot product of u and that answer. Or you can use one of these properties. It does not matter which one you're doing, which method you're doing, but I'm going to show you by using property number 5. So property number 5 says if we have a scalar multiplied by a vector and then we're doing the dot product with another vector, you can actually rewrite it as this. So I'm going to rewrite it as the scalar multiplied by the dot product of u and v. So this will be the scalar 2 multiplied by the dot product of u and v. Now I already found the dot product of u and v right over here. So that's -14. And then we multiply that by 2 and we get negative 28. Example 3. The dot product of u with itself is 5. What is the magnitude of u? So that's telling me if we have the dot product of u with itself, we get 5. We have to find the magnitude of u. That's our goal. So I'm going to go look at those properties. And you will notice one of these properties, property number 4 that I starred before, has the dot product of a vector and itself. And that equals the magnitude squared of that vector. So a dot product of the vector in itself is equal to the magnitude of that vector squared. So I can use the transitive property or substitution, and we can say that magnitude of u squared is equal to 5. And to solve that, we'll just square root both sides, and we will get the magnitude of u is equal to the square root of 5. Magnitude would not be negative because we're talking about length. Example 3b, use the dot product to find the magnitude of vector u with the component form of 7, negative 24. So we're going to use the dot product to find the magnitude. So we're using this formula right above that says u multiplied by u is equal to, not multiplied, dot product is equal to the magnitude of u squared. So I'm going to take the dot product of u times u. That's going to give me 49 plus 576 and when I add that together, I get 625. And once we square root both sides, we get the magnitude is 25. So that's just an alternate way of finding the magnitude using the dot product instead of doing it the way that we learned in the first section. An angle between two vectors. We can find the angle between two vectors by using the dot product. And sorry. In the paragraph here, we're going to find an angle that is only the from 0 to pi, and it says 0 to pi, and then it puts the answer in degrees. So I'm not quite sure why they wrote 0 to pi instead of 0 to 180, but the answer they have for this one is in degrees, or for example 4, I should say. And then please note that the angle between the 0 vector and another vector would not be defined. So the formula is, if we do cosine of theta, that is equal to u dot product v divided by the magnitude of u multiplied by the magnitude of v. So we're going to do that formula right here. So cosine of theta is equal to the dot product of u and v. So 4 times 3 plus 3 times 5. And then we will, in a second, do the magnitude of u and the magnitude of v. I'm just going to work on that top just a second here. And then that becomes, what is that? 27. Okay. On the bottom, if we do the magnitude of u, I'm going to go do it the old way, where I do the square root of 4 squared plus 3 squared. And then we're going to multiply that with the square root of 3 squared plus 5 squared. So that's going to give us the square root of 25 and the square root of 34. So I can simplify that a little bit further. 27 over 5 square root 34. And that's what cosine theta equals. We are trying to find theta, so we need to do arc cosine of 27 over 5 square root 34. By the way, I did not get I didn't rationalize it because that's not my final answer. And that's just extra work that I would have to do, which I don't have to do because it's not my final answer. So that's why I left the square root in the bottom. You can rationalize it. That will not affect the answer at all. So to do arc cosine on our calculator, it's going to be doing cosine inverse of this fraction. So I'm going to type that into my calculator, and I get that theta is approximately 22.166 degrees. Angle between the two vectors. We can rewrite the expression for the angle between the two vectors in a different form, and this is an alternate form of dot product. So this is a different way of finding the dot product if we know the magnitude of u multiplied by the magnitude of v multiplied by cosine of the angle between the two vectors. Oops. Here's just a couple examples of what the orientation of the two vectors could be and what kind of angle that would make and how would that affect cosine. And you can just look at that. That's just for reference. And here's an example. If the magnitude of u is 50 and magnitude of v is 30, and theta is 3 pi over 4. Let's find u dot product v. So we take the magnitude of u multiplied by the magnitude of v multiplied by cosine 3 pi over 4. So let's see. The magnitude of u is 50. Then 30, and then cosine 3 pi over 4 is negative radical 2 over 2. So we will get 1500, negative radical 2 over 2, which gives us negative 750 radical 2. So that would be the dot product of the two vectors, and we don't even know what their component form is. We just know their magnitude and the angle in between. So that is the notes for today. The assignment is, well, there's like 3 different assignments. The assignment that goes with these particular notes is in the book, page 447, 1 to 14 all, 15 to 25 odd. And then you've got 2 other assignments. And this is something that I have the notes written on the worksheet itself, and there's only a few questions on the worksheet. It's not very long. And I went through it, and I just felt like most of you would not get much out of a video. I feel like you can figure it out reading the notes. Now, if you can't, you can totally ask me questions and I can help you for sure. But I just wanted to make a short note video so you really had most of the time to work on your assignments. All right, I'll talk to you soon. Have a great day.